Hey everyone, I hope you're enjoying this series so far. You have already learned so much. Good job. Stick with it. There's 8 parts to the first series, and then we're going to do some super complicated stuff in the second series. But today we're going to be learning how you can multiply complex numbers together. So we've been given 4 plus 2i to be multiplied with 1 plus 3i. So we're going to start this out pretty much like you would expanding a double bracket. 4 times 1 is 4. 4 times 3i is 12i. 2i times 1 is another 2i. And 2i times 3i is 6i squared. But don't forget, if we square I, then we would remove the square root, and that would be minus 1. We can add the 12i and the 2i to be 14i. And we could do 6 times by minus 1, which would be minus 6. So we need to do 4 take away 6, add 14i. 4 take away 6 is minus 2. Your calculator can do all of this for you, and I have a whole series on the Casio FX CG50, which includes videos all about complex numbers. So check that out. Let's have a look at another one, see if we can go a little bit faster now. 3 minus I times by 2 minus 5i. 3 times 2 is 6. 3 times by minus 5i is minus 15i. Minus 2. Minus I times by 2 is minus 2i. And minus I times by minus 5i, double minus there would be 5i squared. The i's can be added together, so that's going to be minus 17i. And don't forget, I squared is minus 1, so this would be 5 times minus 1, or it would be minus 5. 6 minus 5 is 1, 1 minus 17i. Now, let's run a bit more tricky. Here we have to find out what x and y are, but we know that the product of 3 plus 4i with x plus iy is 1 plus 18i. So we're going to be using some of the skills that we learned in the previous video, where we're going to set up an equation of reals and reals and imaginary and imaginary. If you jumped in the middle, I would recommend you go back and check that out. So 3 times x is 3x. 3 times by iy or yi would be 3yi. 4i times by x would be 4xi. And 4i times by iy would be 4 times y is 4y. 4yi squared. Just like in the previous 2 examples, before we start moving things around, we're going to simplify each side separately. So here I'm going to add together 3x, which is real. We can remember that I squared is minus 1. So that was going to be minus 4y here, because it would be 4y times by minus 1. Now what we're going to do is we're going to simplify both sides. Well, this side's already simplified. We're going to simplify the left-hand side to collect together all the real terms and collect together all the imaginary terms. So I like to open 2 brackets like this. Okay, my real parts are 3x and minus 4y. And my imaginary parts are 3yi and 4xi. Now we're going to set up 2 equations. We're going to have the reals on the left-hand side of the equation equals to the reals on the right-hand side of the equation, like this. And we're going to have the imaginary parts on the right-hand side equal to the imaginary parts on the left-hand side. This is obviously going to turn to a simultaneous equation because we have 2 unknowns and 2 equations. So let's rewrite this as a simultaneous equation. I'm going to rewrite this slightly to have my x's lined up and my y's lined up. I'm going to need to times this one by 4 and times this one by 3. So if I times this one by 3, I'm going to get 9x minus 12y equals to 3. Here I'm going to get 16x add 12y equals to 72. Then I can add these two together and that would give me 25x equals to 75. I'm going to move this over here so I get a little bit more space. So that must mean that x would be 75 divided by 25, so x would be 3. I'm going to go back to my first equation here and I'm going to substitute that in. 3 times 3 is 9, take away 4y is equal to 1. If I rearrange that equation, 9 take away 1 is equal to 4y, 8 is equal to 4y, and y is equal to 2. You might want to check that down here. 4 times 3, add 3 times 2 should equal to 18. Well, that would be 12, and that would be 6. So you've successfully solved the equation. One last one that I've noticed in the IB higher level, they can throw you a curveball by mixing in trig identities in with complex numbers. So in this case, we have to expand cos theta, which would be the real part, plus I sine theta, which would be the imaginary part. So let's have a little look at this. So this is going to be cos squared theta add, if we use our identities from the binomial expansion, 2i cos theta sine theta, and then this is going to be I squared sine squared theta. Now I squared is obviously going to be minus 1, so we can rewrite that here. See if you can notice there's some trig identities that they've used here. You might want to pause the video. Did you see them? Well, cos squared minus sine squared theta is the same as cos 2 theta, and 2 cos theta sine theta is the same as sine 2 theta. So they can definitely mix in trig identities to make it a little bit more complicated. So it's getting pretty tricky at the end there. In Key Skill 7, it's going to be quite a quick one. I'm going to teach you how to find the conjugate of a complex number. Please like and subscribe, and like and subscribe, and like and subscribe. Bye for now.